So on this worksheet, we're going to be doing questions 16 through 27. That's a homework assignment. And we should love these types of quadratic equations. Why is that? Because you have a quadratic trinomial and the a value is 1, right? Which means that it's pretty simple to factor. All you got to do is set up your parenthesis, 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 x. And then you could think what times what is the c value that if you combine together is the b value. Now I highly recommend for everybody to make a list of your multiples of the c value, right? So how are you going to get negative 12? Let's just start out with the number 1, like negative 1 times 12, negative 2 times 6, negative 3 times 4. Come up with all the possible multiplication problems that'll give you negative 12, and then you got to think which pair of numbers combines together to give you the middle value b, which happens to be negative 4. So once you have your list, just start combining. What's 12 minus 1? That's 11. That b value is not 11. When you combine 6 and 2, that's 4. That b value is 4, right? So this is the pair of numbers we want. However, when I add negative 2 and 6, I get a 4, and right here it's a negative 4. So I have the right number, I just have the wrong sign. Right here I have the right numbers, I just have the wrong signs. So all I have to do is change that to a positive and change that to a negative, and I'm good. All I have to do is plug it right in, positive 2 right here, negative 6 right there, and voila, we have factored, right? Now, why do we factor? So that we could, on an equation, in an equation like right here, you see, this is this, and it's still equal to 0. So let me put equal 0 right here. And the reason why we like factoring is before we didn't have multiplication. We didn't have something times something equals 0, and now we do have something times something equals 0. So that's called the zero product property. If you have something times something equals 0, the first something could equal 0, and the second something could also equal 0. So this complicated, nasty-looking equation now becomes two simple one-step equations, right? And we could solve both of them. Subtract 2 on both sides. On the first one, you'll have x equals negative 2. And you also add 6 on both sides for the other one, and you will get x equals positive 6. Those are your two answers to number 16, right? Is there any other way to get these answers? Yes, absolutely. If you had a graphing calculator, you could actually type in this quadratic equation that's in standard form. The a value is 1. Of course, it's opening up. It has a pattern 1, 1, 2, 4, 3, 9. And if you were to graph it, the parabola that's opening up would cross your x-axis at negative 2 and 6. All right, so just remember that. On the test, I will give you some equations that are already graphed for you, and all you have to do is identify the answers by looking at your x-intercepts. Anyway, how about you guys try number 17? Go for it. So on number 17 here, again, since it's in standard form, ax squared plus bx plus c, and the a value is 1, you could jump right into the factored form format of parentheses with the x right there and right there. And you simply think, what times what is the c value that if you combine together is the b value? So the c value, that 64, we want to make a list of how we could multiply two different numbers to get 64. And I always start with the number 1, right? 1 times 64 will give me 64. 2 times, what is that? 32 will give me 64. 3 times, will something work? 3 times something? No? Okay, and if you have a calculator, all you have to do is take the 64, try to divide it by 3 to see if you could get 3 times something. Will 4 times something work? Yeah, that'll be 16. Bless you, by the way. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 works. 8 times 8. So once you get your list of all the possible ways, then you just start adding them, right? 1 plus 64, that's 67. That's not 67. This, when I combine it, it's 34. That's not 34. This is 20. That's not 20. 8 and 8, 16. That's 16. But it's a negative 16. So I have the right numbers. I just have the wrong signs, which means I need to change them both to negative 8s. So you have a negative 8 right there, a negative 8 right there. It's still an equation that's equal to 0. And now we're going to split them and solve because of zero product property. So if I have something times something equals 0, the first something could be equal to 0. The second something could also be equal to 0. And then, of course, we solve both, but it's the same exact equation, right? So it'd be ridiculous to solve both. Just solve one. Plus 8 plus 8. Answer is x equals 8. So what does this mean, guys? This parabola, if I were to graph it, just to get you guys, your brain working, if I were to graph this parabola, does it open up or down? It opens up because the a value is positive. As a matter of fact, we already know exactly how wide it is. From that vertex, whatever it may be, you go up, or to the side one, over one, right? Because of the pattern 1, 1, 2, 4, 3, 9. So where would this parabola cross the x-axis? At the solution. Remember, the x-intercepts are the answers. They are the solutions. They're the roots. All those words mean the same thing. So this parabola, does it cross the x-axis at 2 locations, or does it just touch at 1? Just touches at 1. So that tells you a lot, guys. I mean, if you were to think about that, I mean, this is not part of the homework, but if you were to think about it crossing at 8, 1, 2, 3, 4, 5, 6, 7, 8, that's way over here, and we know it touches and we know it opens up, so it's like that, right? So knowing this, you could even tell me what the vertex is of this thing without even using the vertex formula. What would the vertex of this be if it touches right here at 8? 8, 0. That's the actual vertex. So if you actually did the vertex formula, negative b over 2 times a, you'd get 8 as your answer for your x value of your vertex. Then you'd plug it in and you get 0 as your answer for the y value. Anyways, I'm just trying to relate everything here. But on this section, we are factoring, so we could split them so we could solve. I think you guys could handle 18, and actually I believe I already did 18 on a different video. So let's jump right to 19. That's ridiculously easy too. You guys could handle that as well, right? Okay, so we've seen the same type of problem over and over. Now number 20 is slightly different, right? Yes, you have the a value of 1, but you can't really start thinking what times what is a c value, because the c value is not there, it's 0, right? So let's not do that. As a matter of fact, what's the first type of factoring that we learned? Pulling out the GCF. And that's the first type of factoring that you're always supposed to try, right? So no matter what, even on these up here, on number 16, you're technically supposed to see if there's something in common in all 3 terms that you could pull out, right? And obviously there's no x's in all 3 terms. There's no multiple of 4 in all 3 terms, so there's nothing to pull out. You're supposed to check and see if there's a GCF every single time. That's how you start, right? So right here, let's start by trying to pull out a GCF. So let's put parentheses around or the same size parentheses as the variable expression on the left side of the equal sign right there. And what could we pull out? What's in common in both terms? X. Okay, now what would be left on the inside if I pull out an x? X minus 4. Okay, so what did I do here? I just factored out the GCF. Now, why do I factor? So I could end up with multiplication, right? I have something times something, and it's equal to 0, right? So again, if you have something times something and it equals 0, this first something could be 0 and the second something could be 0. So let's actually set that up with the 0 product property. Let's say that first something, that x, that could be 0. And that second something, the x minus 4, that could also be 0. Now, you need to solve both. However, one of them is already solved for you. X equals 0, that's an actual answer, right? And the other one, plus 4, x equals 4, there's your other answer. If you were to graph this parabola with the graphing calculator, it would open up and it would cross the x-axis at the origin and at the x value of 4. Get it? So you always should try to pull out the GCF first and then try to continue doing anything else on the inside or factoring whatever you have on the inside of the parentheses. Now number 21 is a little different. First of all, if we want to factor to be able to apply the 0 product property, to be able to split it and solve it, we for sure need it to be equal to 0 to start with. Okay, so it's not equal to 0. So what am I going to do? Subtract 4x. Subtract 4x. You can't really subtract x squares and 4x's. They're not like terms. So you're just going to rewrite it. 7x squared minus 4x equals 0. Okay? And what do I do next? Parentheses. So I could pull out the GCF, right? Always try to do the GCF first. Still equal to 0. And what could I pull out of both of those terms? X's. There's definitely nothing in common with the number 7 and the number 4, so there's nothing to pull out with regards to the numbers. But there is x's in both terms, so I'm going to pull out the maximum amount of x's, which is simply one of them. What would be left on the inside? 7x minus 4. And once again, we factor to have something times something equals 0, which means that the first something could equal 0, or the second something could also equal 0. Okay? And of course, you solve both, but one of them is already solved for you. And the other one you need to solve. This one gets a little bit ugly. Not ugly, you end up with a fraction, big deal. How do you get rid of that 4? You go plus 4, rewrite it, 7x equals 4. After that, divide by 7, and you're done. X equals 4/7. So your two answers for number 21 are 0 and 4/7. If you check the back, you have your solutions on the back. Those are your two answers, right? This parabola, if I were to graph it, this would be a very narrow parabola. It got vertically stretched by 7, and it also crosses the x-axis at 0 and at 4/7. It's like a little bit more than halfway to the 1. Anyway, I think you guys should now be able to do number 22, correct? Or do you guys want me to do it? What do you think? You guys got it? Yeah. The answers are on the back. How about 23? How do I go about doing 23?
Subtract x squared.
So the deal is this. The reason why we want to factor is to be able to have it equal to 0 so we could split it and solve, right? But it's not equal to 0, so let's make it equal to 0. I am going to subtract the 2x to both sides, rewrite it. X squared minus 2x equals 99, and then I'm going to subtract that 99 from both sides. You can't really do it, you're just going to rewrite it. X squared minus 2x minus 99 equals 0. And now we do have, again, a quadratic trinomial where the a value is 1. So that's that beautiful situation where you do parenthesis, x, x, still equal to 0. And we think what times what is the c value, negative 99, that if I combine together is the b value. Now, if you're totally confused, make a list, right? How could you get negative 99? Well, negative 1 times 99. Negative 2 doesn't work. Negative 3 times 33. And of course, if you see it, don't make the list, right? Well, does anybody see it? What times what is 99? Negative 99. That if I combine together, it gives me a negative 2. Okay, maybe we don't see it. If you keep going, 4, 5. If you get to 9, 9 times what? 11 is 99, right? Now, of course, you want this to be a negative 9 and a positive 11 because that'll give you a negative 99. And if you combine negative 9 and positive 11, will that give us a negative 2?
Yeah. No,
it'll give you a positive 2, right? So we have the right numbers, we just have the wrong signs. So we're just going to change that, and that's what we have in here. We have a positive 9 and a negative 11. So we factored it. Now we're going to split it and solve. Now, I know, guys, that at this point you already know your two answers are what? Negative 9 and positive 11. I already know you know those answers. But I will ask you to show your work on tomorrow's test, all right? So even though you see it, I want to see you apply the zero product property and go x plus 9 equals 0, x minus 11 equals 0, at least that, right? And then you could show me your answer, x equals negative 9, x equals positive 11, okay? All right, 24, all you have to do is what?
Subtract. Oh no,
add 36 so you could get it equal to 0, and you have the same situation as before. What times what is 36 that if you add together is 12? 25 is interesting. Let's do that one. What's the first thing we should try to do? GCF. So what do I pull out? 5. So I'm going to put parentheses around the whole thing. I'm pulling out the multiple of 5 because they're all divisible by 5. What would I have left over on the inside?
X squared.
X squared minus what?
7.
Minus 7 with an x, and then plus 12. I hope everybody sees that, right? And of course, this is still equal to 0. Now, there's a couple of different paths you could take right here. You could either leave this 5 out here and bring it down, because we're going to continue factoring this. because on the inside, we actually have a standard form quadratic trinomial that has the a value of 1, which means that we are able to factor with this factored format and think what times what is the c value that if I combine together is this new b value, right? So thinking of the multiples of 12, it's either 1 times 12, 2 times 6, 3 times 4, and that's about it. Which pair of numbers combines together to give you negative 7? 3 and 4, but it gives you positive 7, so we need to change both of those signs to negatives. That way you have a negative 3 right here and a negative 4 right there. Again, the 5 that you factored out originally, that GCF, you could just bring it down and it's equal to 0. Now, here are the two different roads that you could take. You could, if you wanted to, divide the left side by 5 to make it disappear, and divide the right side by 5, and 0 divided by 5 is still 0, right? Or you could say, you know what, since I have something times something equals 0, I want to do the zero product property to all of them, right? So I want to say 5 equals 0, which doesn't make sense, so you just scratch it out. X minus 3 equals 0, and x minus 4 equals 0. That's a zero product property. And then you solve both. You're going to get x equals 3 and x equals 4. So again, you didn't have to set this up as 5 equals 0 and then scratch it out. That's pointless. You could have technically right from the beginning divided everything by 5. Divide by 5, divided by 5, divided by 5, and divide 0 by 5, which would still be 0. All right, so it's up to you if you want to carry this 5 out or get rid of it right from the beginning. But either way, your two answers come from here and here. When you split them, you get your two answers, 3 and 4. 26. That one's interesting because you have to use that perfect square binomial situation. You want to get it set equal to 0 first, so you'd have to subtract 25. Subtract 25. You have a new equation that reads 36x squared minus 25 equals 0. Now, because we have a perfect square term right here and a perfect square term right there, we could use that method that we learned yesterday, which was taking the square root of those guys and just plugging them into our answer format. The square root of 36x squared is 6x. So you put 6x as the beginning part of your binomials, as your first term in your binomials. And the square root of 25 is 5, so you put 5 right there on both of those. And now it's just a question of the signs that belong right here in front of the 5s. What do you guys say? You want them to both be positive, both be negative, or one negative, one positive? Absolutely, one negative, one positive, right? One negative, one positive. And it doesn't matter which one you put where. The bottom line is when you distribute, if you were to distribute, your final distribution would be a 5 times 5, but you need it to be a negative 25, so that's why we put a negative 5 times a positive 5. That's the only way you're going to get a negative 25. And not only that, if you were to check your answer, when you distribute, the middle terms will cancel out if one's negative and one's positive, if it's the same exact two terms on both. All right, so we still need to solve it, so you split them and solve, right? 6x minus 5 equals 0. 6x plus 5 equals 0. So you're going to add 5 to both sides. Sorry, I'm running out of space here. 6x equals 5. Final step would be to divide by 6, and x equals 5 6. The other one, subtract 5. You have 6x equals negative 5. Divide by 6, x equals negative 5 6. So those are your two answers. Is there a different way of doing it? Yeah, you could technically get x by itself by getting rid of things, right? So you could divide by 36 and divide by 36. Do you want to see that other method or just stick with that? Stick with that. All right. Number 27. Okay, so I'm not going to explain it completely, but you could pull out the GCF, which would be 2, right? That's what we did on the previous problems. Pulled out the GCF. Or you could say, hey, this whole thing is an equation, which means I could do whatever I want to it as long as I do it to both sides. So you could technically divide everything by 2 if you wanted to. That way you end up with x squared minus 4x minus 45 equals 0. And now you have the standard form quadratic trinomial with the a value of 1, which means you'll be able to set that up. And then think what times what is negative 45, that if you combine together is negative 4. It'll be factored, you split it, you solve it, you're good. All right, so I will select, I'm telling you right now, I will select 5 of these. 5 of these will be on the test tomorrow, okay? And that's this part of the test is small compared to the rest. The majority of the test is all about graphing parabolas. So if you want a better description of what we're seeing on the test, go back and watch the previous video in review for the test.